Alright, so we're still in the same class, which is great. Today, our goal really is to figure out what did the data tell us. Long dramatic pause. What did the data tell us? And we're going to play with that Razorback score data set. Okay. I have something that I want to try. I don't know if it's going to work or not. So I have a couple of avenues that we're going to pursue. Our big agenda today is we're hitting into lesson 4. Okay, we're going to talk about chapter 8. Chapter 8 is what your quiz is going to be over. And then we're going to focus a lot on SAS. And hopefully at the end, depending on how our SAS goes, we'll get into Tableau. Okay? So if we fly through SAS, we'll spend a lot of time on Tableau. If we spend a lot of time getting into SAS, then next week we'll spend a lot of time on Tableau. So just depending on how the day goes. So where we've been, right? We talked about descriptive statistics, we talked about sampling and our data integrity. A2, assignment 2, if you haven't turned it in, is due tonight, 11:59, not 12:01. I extended it from 8:30 to so plenty of time. Okay, so A2 is due tonight. Quiz 3, like I said, everybody's turned it in. Congratulations, way to go. I did get some emails about one of the quiz questions, so slight detour. I graded my Saturday classes. The most missed question was the question about the sampling. So I gave you a scenario and asked you which sampling procedure to use. You were like, yeah, that one, that's the one. Okay. So here in a second, I have a slide about sampling, so we're we'll talk about that in a second. Do you guys have any questions specific to the assignment? Like last minute burning questions, or you just need to finish it? I mean, I feel like asking it's fine. Okay. You don't, it's not due till tonight, you can hold it. Aside from class time, there's life time. Okay, so no like burning last minute, everybody's good. Okay. So we talked about data cleaning. I'm going to do a little bit of data cleaning in SAS today. The sampling methods. So the scenario that was on your quiz was something to the effect of, come on in. Okay, was something to the effect of, we want to figure out cell phone, smartphone usage. Right? Everybody's remembering this question. It had something to the effect of, I'm not going to read the exact question from being recorded, but basically something to the effect of, we want to figure out smartphone usage in a country. So in that country, I'm going to randomly select counties or areas in that country. And then once I've selected those counties or areas, then I'm going to sort them by those counties by highest population. And I'm going to take a random selection of those, and I'm going to sample everybody within that county, or within that area. And that was the essence of the question. Yes? So given that scenario, what would you select as an answer? What type of sampling would that be? Cluster. Okay. Now the second most popular answer was stratified random sample. Okay? So if someone wants to argue with me, here. So why would you pick stratified random sample?
See, if the quiz had actually been for 5 minutes, I would have gone with cluster because that's what I chose first. Since it was 1 hour, I really thought a lot about it. See, the main logic behind cluster sample is that every cluster should be representative of the population. Am I right? You choose multiple clusters and each cluster is more or less representative of the population. And then you select clusters in random.
I hold that a little, yes, okay, keep going.
So, when I thought about this mobile phone example, and I was thinking about how the clusters, when you are selecting it across various regions, it might not at all be a representative at all. For example, north and south might be totally different, and
yes.
east and west could be different, and a city in urban and a city in rural could be different.
Yes.
So I was thinking maybe a cluster is not the way to go, and therefore I thought maybe a stratified would actually make more sense. Because
So we have two questions here. So does somebody else who chose the stratified want to agree, disagree, add to what he had?
I disagree. My understanding was, based on my research in when I Googled, cluster gives you not a homogeneous population. Stratified is more like, supposing you consider population as colored balls, the example that was given was stratified is like you have groups, but groups of different colored balls, whereas clustered is like you don't get a homogeneous population, you still get groups of heterogeneous populations. So I thought that was my basis for selecting cluster. Stratified is more like you're comparing two
Go with it.
totally different colored balls.
That's a horrible picture. Somebody go with me on this one. Someone pretend, just pretend. That's what That's even worse.
This is fun.
Wyoming. Go with
Oklahoma.
No.
What?
Wyoming and Colorado. Yeah.
That was totally Oklahoma.
Yeah.
I can draw. That's where I'm from. I can draw Oklahoma. Arkansas still gets me though. I mean,
I can draw Louisiana.
I like that. Arkansas.
To be clear.
You guys know what I'm talking about. Oklahoma.
Keep going.
Arkansas.
Texas. We're on Texas artists.
This is just a fun game now. So, point being, going back to, okay, so I agree with what stratified random sampling is. I understand where you're going. So someone else who picked stratified random sampling instead of cluster sampling, do you want to add anything, argue anything?
Yeah, so for me, like, my interpretation was kind of just that they were separating it out into the different cities and sampling from each. That, to me, seems like they were separating out in different strata, taking a sample from each so that they were getting.
Okay. So ideally, for the stratified random sampling, we would have criteria, right? So for this one, we have some criteria. And it could be, but it's to make a strata, right? So whatever criteria A is, B, criteria C, and then you would randomly select, so out of Oklahoma, all the people who have A, and then there's people with Bs, and there's people with Cs, and you would find all of the As who are individual people, and then randomly select from all of the A's. Whereas the cluster sampling is more of an area thing, or a group thing. So here, right, all the little counties in here. So we would select a county, and we would take everybody in that, or a representative sample of everybody in that county. So to your point, no, cluster sampling does not guarantee that it is representative of the population. Ideally, it should be, because if you have an area and you randomly select different areas, and then you select from within those selected areas, it should be representative, but it's not guaranteed, because if we randomly selected things, we could get more people from the north and totally miss people from the south. Or if it's a more urban population and a less rural population, our random samples could be 90% urban and 10% rural. So, two different questions here. Given this scenario, cluster sampling was the better fit for the scenario. Given the idea, stratified random sampling may be a better choice for the sampling procedure to get the information that you're looking for. Does that make sense? So the difference between like a test question and an overall open-ended question, right? So if I would have made that question open-ended, you could have argued cluster or stratified, right? If I just said, here's what I want to do, how would you do it best? Both answers would be correct. The way the question was worded itself, I selected an area and then I selected from that area. Clustering was better than stratified just because of the wording of the question.
Just to add the wording of the question, if the question was, which sampling is this? It would have been clustered. But which sampling would ideally suit for this? I was thinking, okay, now it's not clustered.
So I need to work on the wording. So because of that, and because
I think one too much of trick questions in there.
I don't do trick questions. I assume it's as simple as it gets. But because of this discrepancy, I have no problem going back and giving at least half credit for those people who chose stress. I haven't decided how much yet, but I will say at least half because you argued well. It may be a full point. I don't know. I haven't thought about that part yet. But at least half. That seems fair? No. It's a question that could have been worded better. Right? It could have been worded more clearly. You have good reasons. And there was more than two of you who did that. Right? So if it's just two people who do it, then I'm like, eh. Right? There was, I don't know, probably 20% of the class made that, and I'm hearing from different people their reasoning behind it, so. Seem fair? Brilliant. We talked a lot about sampling methods. Any other questions about sampling methods? Hold on, I'm going to write myself a note so I actually do it. All right. We talked about point estimation, right? The idea that we can do descriptive statistics. We got one value, so we take all of our data, 1,000 data points, and summarize it with one number, a mean. And summarize the variability with one number, a range or a standard deviation, right? Point estimates. We talked really briefly about the central limit theorem. What was the magic number for the central limit theorem? 30. Any questions about stuff we've done over the last 4 weeks? So we started to spend a little bit of time with that Razorback stores, right? We spent some time data cleaning. 90% of you use Excel. A few of you guys tried to play in SAS. So our Razorback, our initial data set, had these variables, right? We had our customer, our type of customer, how many items, the net sales, the payments. We had some descriptive statistics. We had some times, some birth dates. We had some information about our loyalty customers. Okay. We talked about all the things we could do for data cleaning. Okay? So what I did yesterday was I used the query builder to do all of these things that we mentioned. So a lot of you did this in Excel, which worked because we only had 1,000 data points. But if we were trying to do stuff like this for our Dillard's data set, our Sam's Club data set that's got 1 billion records, Excel's not going to play nice with us. Okay? So things we did, just fixing typos. Query builder can handle that. One of the things we didn't talk, we didn't talk about, like data entry errors, right? We had negative values. If we have negative net sales, how do we fix that? What do we do? What does that mean? So if we have a net sale, and it's a negative value.
It's a loss.
Okay, it could be a loss.
It's a return.
It could be a return. Right? So if we assume that it's accurate information, it could be a return. Okay. What if we assume that it's inaccurate information?
Just multiplied by -1.
Okay, so maybe it's not a negative value. Maybe it was just somebody hit the negative and it really should be a positive value. What if it was supposed to be, what the negative value is kind of close to a 9? What if it was just a typo? What could we do? How could we fix these negative values? Yeah.
Well, it looks like you imputed the mean.
It's difficult to think it's other words.
Dang it! Somebody looked at my slide. So that's one option, right? So options are, number one, we assume that it's true, and we assume that it is a return. Okay. And then we just operate under that assumption, and we say negative values are okay. But we have to make sure that we're clear on that, and then start to wonder why, over the course of an entire week, we only had 3 returns. So you what?
Great products.
Great products. This is awesome. Like, we don't really do returns. Okay. So if we assume that that's a normal amount of returns for us, 3 returns out of 1,000 transactions, then we can just use the data, but know that we have negative values in there. We have 1,000 data points. We only have 3 negative values. Could I get rid of those observations?
I would get, no,
I wouldn't recommend it.
I wouldn't do that.
Okay. So don't get rid of the whole observation. There's a lot of information there. Why would I get rid of the whole observation? Okay. Could I just get rid of that one data point? Just make it a null? Like, I'm not sure what it is, so I'm just going to make that a missing data point.
You could, depends on if the software can handle the null.
Okay.
I mean, if you're certain you'll never get audited about it.
So this we're assuming this is for our analysis. So they're still going to have the actual record.
Okay, cool.
We're not changing the historic data. So the data's there. This is us doing analysis on it. Right? So maybe we make it a negative data point. So here, I replaced it by the mean. Is that a good idea or a bad idea?
It's a good idea. It's almost like doesn't impact the rest of the.
Okay. So if I'm doing calculations and stuff, it's not going to impact a lot of things. Well, it's not going to impact the average. What could it impact, though?
Range, deviation.
The mode.
Okay. The range, the deviation, the mode. It could change the mean a little bit, right? So the question is, when you put in the mean, do you do the mean with those values in it, or do you take those values out and then compute a mean and then replace it with that new mean?
But we are assuming something like we are assuming like 0.3%, so it's not going to have much of an
Okay, so it's not going to be that big of a deal. What are you thinking?
Does it really matter as long as your audience is aware?
Oh, another great point. Do I have to disclose it to my audience? Do I have to disclose my data cleaning methods to my audience?
No.
I got people over here going this, and I got people back there saying, no, why would you do that? These are things we're going to think about. We're going to talk about these all throughout the semester on different data sets that we use. Okay. So this is what I did this time. We may change our mind. Okay. So in my head, the thing that I'm thinking of that would make a big difference, what if I'm interested in my total net sales for the day?
You want them negative.
Right? So if it's a negative and it's a return, then I really need to keep that return, because that's actually a loss of $150. If I replace a negative value by the mean, that $157, now I'm adding to my total, so I could potentially be inflating my total sales. Right? So these are all the things that we have to think of, depending on the analysis we do, how our data cleaning can make a big deal. Okay. The other thing we can do, I rounded some data, or rounded some values because we have net sales and gross sales. So I rounded to the 2 decimal places because it doesn't make sense to have 3 and 5. And then I had a lot of fun, and I replaced inappropriate values with missing values. Yes.
If you're concerned about the negative value,
Mm-hmm.
and it's important to, like, if you're reporting net sales, why don't you just go find out if that information is valid? Like, because if it is a return, you don't want to delete it from your analysis. So why just, like, play around when you can go find out that information?
So I'm Razorback Stores, and I had 1,000 transactions over the week, 1,000 credit card transactions over the week. I could totally, absolutely do that. Now I'm Dillard's, and I had 1,000 transactions at one store in a day, and now I'm trying to look at a week's worth of data. So now I have, depending across my stores, millions of data points for this week that I'm trying to look at. But I want to go track down every single discrepancy.
With respect to claims, typically returns, there will be like a transaction code or something which says that this is a claim, so we can probably try to match it. It's just a few data points that we're looking at. We would be able to compare and say that, hey, the transaction code for this was claimed, so we should be able to take that's taking care of it.
Okay. So more questions come up, right? So now we're talking about, back to that data integrity part. So when the people, whoever gave us this data, this is a great question, right? So for the people who gave us the data, how did they give it to us, right? A thing that I kind of have, but yet don't have, is a data dictionary, right? So here, I tell you what the data values are. But if I wanted to let negative numbers happen, I would probably put some more information here that says negative value represents a return. And if I knew that, then this whole conversation we had doesn't mean anything, right? So if we know about the data and know how the data are input, right, how we pulled the data, then that helps a lot, right? And then if we just have those few errors, then we can go track down a few errors, right? So ideally, in our millions of data, if we only have 100 data points or less, we could go track them down and see what's what. So these are things we're going to want to think about. So for our data set, we'll think about it. For the data set you're going to pick for your final project, these are things that you are really going to have to think through. And you're going to have explanations for why you chose to clean your data the way you did. Okay? Because if our data owner comes back and says, hey, this really isn't what I was expecting, this number's a lot higher than what we think it should be, you need to be able to tell them, well, to do this analysis, we actually excluded this. Or we modified the data by this. And then you're like, oh, okay, totally works. Or, yeah, you can't do that. Yes.
I mean, the data from respect to data cleaning, my question was, what are the guidelines to say that this falls within the data integrity boundaries? I mean, things like female to male, those corrections are like very basic.
Right.
Accepted.
There's some obvious things. When you're fixing typos, yeah.
But you just brought up negative values.
Mm-hmm.
There would be so many such observations or data points. Now, will the corporate tell me that, okay, these are the boundaries accepted? Will the business decide that?
Yeah, a lot of it's going to be your content knowledge, right? So you know from your business what you can do and what you can't do. And this is where people start to get into trouble when you have a very large corporation, right? And this group is doing data analysis on this, and this group's doing data analysis on this, and you actually start to talk to each other, right? There's certain things we can say, since we have the accountants in here, the money shouldn't change, right? No matter where you go, no matter what you look at, the finances should be the same. But when you start trying to do predictive models, then the question becomes, what data are you using? Are you using all the data and allowing for noise? Are you trimming the data and only using the middle 90% and getting rid of all the outliers so you can have better predictive? And there's all sorts of things that we'll address throughout the semester. So part of it will be, what is the culture? What is your content knowledge of the subject main, right? So here, if we were talking about times and we had negative numbers, everybody's like, data entry error. That doesn't make sense. We don't have negative time. But when we start talking about net sales, now you have plausible reasons for negative values. These are just things that we'll think through given the different data sets. And as stuff comes up throughout the semester, we'll talk about it. Okay? So, let's see what we can do. Why don't you guys get into Enterprise Guide. We're going to try something.
I have one more question. What's the difference between enterprise guide and mining software? I could have Googled it, but
So Enterprise Guide versus Enterprise Miner. So it's all a SaaS product, and SaaS has Enterprise Guide, which is kind of like the hypothesis testing, the trying to think of a good word for it. Basically, the inferential statistics.
okay.
So it's their point-and-click interface for the inferential statistics. And then they have SaaS Enterprise Guide, which is their data mining, and that's what it's focused on. So Enterprise Guide has a little data mining. Enterprise Miner has a little bit of inferential statistics. They have a new thing we're going to learn later in the semester called SaaS Via. It focuses more on the machine learning aspects. They have a SaaS Text Miner. Focuses on text mining. We'll do that next semester. There's SAS 9.4, which is the programming language that runs all of it behind the scenes. So it's just a different product. All right. I need, and because you are straight in front of me, who has Enterprise Guide pulled up? Go open projects. I want to do this with one person because I haven't experimented yet, and if it works, then we'll do it to everybody. Okay. Navigate to, where do you start at? Here's my own folder right now. Okay. Go back to the ISYS 5503 Keeper folder. Okay. So you can see everybody's name. Do you see an EKP folder? Sorry, take time out. Almost. Okay. Okay. Click on my folder. You see a whole bunch of junk? Yeah. Okay. Click on Razorback Stores 30. Wait. Yeah, click on it. See what happens. Excellent. Okay. So, what I want you guys to do, these are very, very important steps. I want you to follow along very closely. Okay, ready?
Yes.
Okay. File. Open. Project. Okay. If we start at the server, so we start at the very left-hand side. Server. We're going to the D drive. You guys know where we're going, but nothing slow enough. SaaS app. Files. Wait for the clicking stuff. D drive. ISYS 5503 Kiefer. You guys are well familiar with this path now, right? Yes. Okay, just making sure. Okay. Now, you should see everybody's name, all the things. Yes.
So just a quick question. For assignment, the data set, there was also there inside assignment also was there outside the same data set, right? Because I used the data set that's outside the assignment folder.
Yes, the same one.
Same one.
Same one.
Cool.
Yeah. Now what everybody gets to do, now remember you can only do this when people say, yes, you can do this. Go into my folder, E-K-E-I-F-F-E, E-Keepy, go into my folder. Okay, look, there is a bunch of stuff. Don't play with it unless I tell you you can. Okay. These are not your assignments. Don't think you're going to get an edge. These are the assignments from last year. They're different. Don't look at the final and the midterm. This was last year. It's bad. Don't look at it. Okay? Razorback Stores, we're doing Razorback Stores. Click on Razorback Stores 30.
Oh, yeah.
Don't do anything. Don't touch it. Don't do anything. Don't think about it.
My file.
Does it look like this? Everybody has this. Bunch of stuff on the left, pretty little waterfall looking thing on the right. Yes. Okay. Right now, before you do anything, file, save as. Do not mess with my stuff. File, save as. Put it in your folder and attach your name to it. Okay? That way we do not get it confused with mine. I'm going to save it again. Here's my backup copy. Okay? So it is your copy. Make sure. Where does it say it at? Up at the top. Make sure it says Razorback Stores Dirty and then your name attached to it. If your name's not attached to it, don't mess with it. I worked really hard on this. Okay?
Do you have a backup?
I just backed it up. If you look at the top, it says backup. Yeah, just back it up. Okay. Everybody's good. Okay. So what I did, good, saving, good, saving, making sure. Not that I don't trust you, but I don't trust you. Okay. So I've gone through a lot of different ways of how to do this, and I thought about going step by step and kind of showing you how to do all the things. Instead, what I did was I created Razorback Stores, and this is how I cleaned the data, did descriptive statistics stuff that's basically assignment 2 stuff with the Razorback data set, and then we'll use this today for confidence intervals. Okay? So I'm not going to go over everything step by step, but it's here for you. You can dig into all of this. Okay? So a couple of things I want to point out. Some things that I can show you. Yes?
Maybe a little stupid question, but
Nope.
supposing I have a similar cleanup,
Yes.
program, and I'm trying to run this against, say, 20 million records or something like that.
Yes.
And I've already gone through this whole, I've spent like 4 hours, I don't know how long that takes. And I've cleaned it up to 80%, and then suddenly the power goes off, end of the day, and I need to complete the 20% tomorrow. Is this cleaned data cached in ISYS, or is there a way to save it? And so that I can continue from there on their end.
Okay. Great question, because that's actually where I'm going with this, right? So we start with a data set. Okay? In our case, it's 1,000. It's not that big of a deal. I'm going to do some stuff to it. This is the query that I'm going to use to clean the data set. I do some things with it down here, and we'll go through this in a little more detail. Down here, I'm going to go through things. I'm going to do some more cleaning. I'm going to add some variables. Okay? I'm going to do a few analyses. I get a little bit farther, and I realize, I need another variable. So I'm going to add another variable here. Do some more analyses. I need one more variable. So like I'm adding variables as I go, as I need them. So this right here, this data set is my best data set. It's the cleanest. It has the most variables added. So yes, I could export that data set as Razorback clean if I wanted to. And with 1,000 data points, even though I've added I think I've added about 10 different variables, that's not that big. But if you had 20 million rows, the idea behind saving this project is that you should be able to run this project and pick up from where you left off and not have to save a duplicate of those 20 million rows. So you should be able to pull in whatever data you have, and whether that's the same data set or whether it's a new data set that you want to run the same procedure on, right? So every week you have to run this same idea and you need to clean it every week and you need to do all this stuff every week. You should just have to replace that first node, all the rest should work. So twofold answer there. Yes, you can export your data at any stage. But ideally, by saving this program, you won't need to do that. You'll just need that one source file, and then it'll run through it and do everything.
I mean, my question was not with respect to the program, this particular program, but does it persist the cleaned data? That was my.
Right, and so no, right? I mean, so it stays in a work library, that persists, but when you get out of it, then it goes away.
So it's cached.
All right, so how do we want to do this? This was my plan. So the data cleaning piece, right? I did a lot of different query builders. So if you go and look at what you have in front of you, and now you can play with it. Okay, you can mess around with it. If you screw something up, sure, it's not mine. Okay? Don't mess with mine. Okay, so here. If I click on, oh, I didn't do it. Man.
None of us messed with it.
No, this is okay. Okay. Let's see if I can do it somewhere else bigger. Duh. Okay, so I'm not going to be able to illustrate it. But if I could, some of you have had issues with your assignments. Okay? You've saved your project. You want to go back and do something on your project. You click on one of these reports, and what happens is you get this little yellow bar. Anybody got the yellow bar? The yellow bar that says something to the effect of work, query, something doesn't exist. If you haven't gotten the yellow bar yet, you will.
One day.
So it's a matter of time. I was hoping I was going to get to show you, but I guess I ran this too recently. So generally it happens when, like, overnight. So like you run your assignment, you've logged out, overnight, things clean out, and then you get back in the next day and you try to click on it, and it's like, sorry, your work library hasn't persisted, right? Can't use it, no results. Yes?
Database is like the second one.
This one?
The query is not opening.
Ah,
Just the
perfect!
yellow bar.
Yeah.
I just said.
Yay! Good job. Okay, yes, this thing right here. You can't open the query. Can't do it. It's not working. Okay. There's a simple and easy fix. You do not have to rebuild your query, because that totally defeats the purpose, right? All you have to do is go back to your process flow, and right next to your project tree, there's a run button. Click the run button, and we're going to run the project. We're going to run the whole thing. This is either going to be a really good idea or a really bad idea with 30 of us in here.
Oh, that's so cool.
Okay. So it's taking a little time, so it's going to show you. So the yellow, you can watch its progress as it goes through. If I've made any updates on any of the data sets, it's now fixing it. Life is good. Okay. And so I've done a lot of things on this project. Okay? Initially, I had the idea that I would clean it in one project, and then I'd have a clean data set, and then I would do other things in a different project. And then I just started doing things, and I just kept going. But then, over here, in our project tree, in our project flow, and I can't make this bigger, which is why I wanted you guys to be able to have it on your screen. Okay? When you run a summary statistic, okay? It just says summary statistics. And then when you run summary statistics again, it says summary statistics 2. And then summary statistics 3 and 4. Well, if I want to try and go back and figure out what I did, or where the results or the output is that I want, you just got to start clicking around a lot. So you can edit the names, right? So you'll see mine. This is the summary statistics for the original data, and the one-way frequency for the original data. And then I did some query builders to clean the original data. And then I did some stuff on the clean data set. Here I filtered based on loyalty equals 0. So now when I go back to this filter, I know what I filtered the data on. I did another query builder, and this time I wasn't cleaning the data, I was adding variables. Okay. Here I did a bunch of analysis with net sales. Here I did some stuff down here, net sales by age range. So now I kind of can go back and figure out where my output is. Hints, tips, tricks as we start to do this and get bigger and bigger projects. Okay. That's all the staff tricks for today. Let's explore a little bit. So this is stuff that you should already know how to do. You have the SAS output. You can go through this. Okay. But I have a business question. How many or what percentage of our sales are between 100 and 150? That's my business question. I want to know. People come in, what percentage of them are spending between 100 and 150 bucks? One of the key skills that employers are looking for. Ooh. Pops up right there. Are someone who can take a business question and change it into an analytics question that people can answer. Okay. So how many or what percentage of our sales are between 100 and 150? Given the data that we just had the net sales column. Could we answer that question? Directly? No. So we could potentially filter, given some criteria between 100 and 150. Okay. But then you did such a great job telling me between 100 and 150, now I want to know between 150 and 200. So now you're going to have to go back to your desk and filter again. So is there a better way?
Yes.
Yes! Is it just because I said, is there a better way? She wouldn't have led like that if she could, right? Excuse me. So yeah, so filtering is totally a way to do it. Okay. But we're also trying to think long-term, how do we get stuff going on? So creating that range, 100 to 150. Or if you wanted 100 to 125, 125 to 150, and then add those together. Right? So you can create it at different levels. Okay. We can use our query builder to create a net sales range variable. And then it's just a one-way frequency table. Query builder. Just do the between this value and this value. We do our query builder. We can get a histogram if we want one, or a bar chart in this case. So let's actually go to your question real quick. I said you could do a histogram, and then I changed my mind and said a bar charts. Why did I change my mind?
Because they're not touched.
Okay, because they're not touching. So visually, I'm like, that's not a histogram, that's a bar chart. And the reason it turned into a bar chart was because I have qualitative data, not quantitative data anymore. Right? So, I cleaned my data. And again, you guys can just click around in here, have fun, look at it, see what I did. I'm going to go down to this part right here, where I'm using my query builder for adding variables. If I modify the task and go into the computed columns, because that's where I was doing all my things, I can find this net sales range, and I can edit it, and you can see what I did. Okay? So this is just, you guys have the ability to dig down into anything you want to dig down into and see what I did. If you see output you like, you can go back and look at the settings. What did she do? If you want to see, well, she made this new variable, how did she do that? You can click in here and find it. Yeah. So I went to, coming down past the first query builder into the second query builder. It says query builder adding variables. And again, why it's nice to name things, right? and then you can just modify the task. And if for some reason, like I've had trouble last night, modify task wasn't always there. You're like, oh, I want to change it. If you are over here in your project tree on the left-hand side, if you right-click on something, you can run it and modify it. So even if the modify isn't over here where you normally see it, you can right-click and modify it. Okay, so again, computed columns. I'm editing this just so you can kind of see what's going on. Cancel out of this. When I cancel out of this, the next thing I did was I did a one-way frequency. So that's for net cells. I really did it for net cells range. So if I go to modify that task, and I think this is your question, if not, get me right here. So here we have the triangle, which is our categorical variables. And I can do certain things with categorical variables. And up to the left, you'll see this task roles, and you'll see it has a triangle, it has a clock, and it has a blue circle with numbers in it. So that means that you can use any type of variable, and you can make a one-way frequency with it. Okay. But you'll notice with the frequency count, it only lets you do numeric variables. Okay, so different types of variables are going to let you do different types of things. Does that kind of address your question? Okay. And so, in some cases, if we're trying to do a histogram, and here, actually, let's go back to the next thing I did. I did some summary statistics. So I'm going 4 things down here. With the summary statistics, if I modify that task, you'll notice that the only thing that I have as a task option is the numerical values. Right? Because I can't do means, medians, modes of categorical variables. So SAS is like, I'm not even going to let you put a categorical variable here because it's not going to work. So does that kind of make sense? Alright, how are we feeling? Do you like having my project? Click around, have fun, it's yours to play with. Don't touch mine. So does anybody have questions about how they would need to do this, right? Because this was something you kind of had to do for your assignment. Right? You used the query builder, you built it, changed the numeric variable into a categorical variable, you made a frequency table. You also, same question, I could have constructed a histogram, although that doesn't make too much sense, or a stem and leaf plot. To do this, and I made it, so I tried to write, and this wasn't the important part, so that's kind of why I have it really down here in like teeny tiny fonts. So to get your histogram, or to get your stem and leaf plot, which I had several questions about that, describe, distribution analysis, and then there's a checkbox in the plot section for text-based plots. And that's where that stem and leaf plot comes from. And on your homework data, it looked kind of pretty. It made sense. We had 50-ish data points, I think. We've got 1,000 now. When I did the stem and leaf plot, not exactly the same thing. Our values range from 30 to 290-ish. For net sales. We're not going to make a stem and leaf plot that big. Okay. So it basically made a histogram. Each of the little asterisks represent up to 9 counts. Okay. So it's not exactly the same with big data. That's why we don't use stem and leaf plots. Let's try another question. What are the demographics of our customers that spent the most? What about our customers that spent the least? I should have had this animated so you couldn't already see my suggestion. But if you had to just answer that question, so imagine that next bullet isn't there. If you had to answer that question, okay, so I have this data, I have demographics, I've got net sales. Tell me about my customers that are spending the most. How would you do that?
Identify the factors or the democratic factors which are important to me, like is it by marital status, is it by whatever, age group, gender, so which factor, what is the angle by which I want to.
So are you looking at demographics first, and then looking at information based on that? Or are you looking at who spends the most and who spends the least, and then looking into the demographics?
First, you need to look at who spends the most, and
Okay.
then look at the demographics.
Okay. So first we've got to get them into at least two different categories somehow. Okay. So what's one way you can do that? You can just sort the data. Right? So for one of your questions on your homework assignment, right? What was the highest state, what was the lowest state?
Yeah.
Right? You could have just sorted your data, looked at the highest, looked at the lowest, and you're done. How many of you guys did that? Okay, that's a great way to do it, right? 50 states. I'm only looking for the highest and the lowest. Sort your data, and you're done.
We have not yet submitted that same.
Huh? That's okay. Now you have now nobody should get that one wrong. I didn't say what the answer was. They gotta go figure out it's Idaho and whatever. New Jersey, Idaho, New Jersey. Nobody knows it's Idaho and New Jersey. But yeah. Okay, so we could just sort the data, right? So here I sorted the data by net sales. The top is the people the 5 who spent the most money. The bottom is the 5 who spent the least money. I can just kind of eyeball it. Well, they're all promotional customers. That doesn't help. Most of them spent a lot of items. If they spent a lot, they bought a lot of items. If they didn't spend as much, they didn't buy as many items. Razor card and MasterCard, pretty much. Mostly females. Same proportion of married and single. Their birth dates have a pretty good range. Their date of purchases have a decent. They like the 19th. The people who spent the most like the 19th a little more.
Yeah.
But I'm only looking at 5 people. Right? Time of purchase. Mostly in the afternoon for everybody. 4 out of 5 are loyalty members. So really, I'm not seeing a demographic that's really helping me out. Just looking at the top 5 and the bottom 5. Just like, yeah, customers. So what's another way that I can do this? So I'm going to do a lot of visual scanning. How many, I looked at 5 and 5. How many should I look at?
Could you group it into like the quartiles maybe, like the upper and lower, and then like make a separate table of just that data, and then run like statistics on that?
Sure. I like the quartile idea. So look at the bottom 25% and the top 25%? Yeah. Quartiles, good. I didn't go there. I like that. Right. So quartiles, you can do quartiles, and again, right, filter, I heard filter, right? So you filter, you figure out what the quartile value is, and then you filter everything below that number, and now you have a new data set. Now I can do descriptive statistics on this new data set. Okay. It's a great idea. Any other ideas?
You know, doing more and more of these grouping. My mind keeps going back to the Simpsons paradox. So how do we not worry about that? You find these patterns, but then when you look at the whole population, then it goes away and it reverses.
So it all depends on your business question, right? So if I'm looking at as a whole, then the demographics that I pick may not be the same. But if I'm only interested in saying, okay, in my mind, the theory that I have is I want to figure out who are my top spenders, and I want to attract people more like my top spenders. Then, my business question is just top spenders. And even if demographics for my best people are in something else, my business question is just talking about this situation. So then it's okay. Or if I'm just talking about my low spenders, or just. But I have to be careful and not generalize to my entire population. I can only generalize to, these are my high spenders, and I want to figure out how to get more people like this. Or, alternatively, these are my low spenders. What's the difference between my low spenders and my high spenders? Right? If it's just the loyalty program, then maybe my goal is to get these low spenders into my loyalty program, and they'll become high spenders. Right? Or maybe my high spenders are all females and my low spenders are all males, and maybe I want to do more promotions to men, especially around Mother's Day, Valentine's Day, whatever, and get them into my store. And maybe they'll become higher spenders. I have no idea. Right? So that's where your marketing team and all that comes together with the data that you have. But you have to be very clear on, here's the answer to my business question. Not here's information you can use for all. Agree with that? So I took your idea-ish, and instead of doing quartiles, I used my net sales range, because I already have things broken up by who spent $0 to $50 and who spent $50 to $100 and so forth. And so I looked at the filter and sort by some criteria, and then I did some visualizations. Yes, I realize you can't see them very well, and I apologize. But you get the gist of it, right? Almost everybody. So here, for my most, who was spending the most money, I had 57 people in that top tier. That they spent $250 or more. Most of them were promotional customers. So we got 60-40% on the married single. Most of them were female. They had a distribution of the type of card they used. A lot of them came in on that second day. And then we kind of had an upward trend, and then we kind of went down. We lost some people over here. For my least, same thing, mostly promotional, different regular. Here I've got a bigger differential between single and married. Instead of 60-40, now I'm at 75-25. So maybe married is a variable. Marital status might be a variable I'm interested in. Female to male, we just have more female shopping at our store. That's not going to make a difference, really. Still kind of a good distribution. Here the pattern changed, right? So still most everybody got our sales on the 19th. But here where we dipped down on the 23rd, this group actually went up on the 23rd. So our lower spenders are spending more on this day, whereas our higher spenders kind of go up and then actually taper off on that day. So what's happening on the 23rd? Do we just have less people in general? Oh, we can go and investigate. Just questions we can answer. Can you guys make these charts, make these plots? You comfortable with that? What about more generic? Tell me about our sales for this promotion. Overall and day by day. So as you're looking down in my SAS output, so all of these things you're seeing on the slide here came straight out of this guy right here. Okay, so here we're still in our data set. This statistics, this net sales, is what we're about to see, and then net sales by date. You're about to see this. Okay. So that's where we are in terms of what I've been doing. So we've got net sales overall. So overall, what's our average? Well, on average, somebody spends about $158. It's kind of nice. And I did the sum, so total for our week, we earned about $160,000. Kind of nice. Kind of a nice distribution. Some outliers above and below. How did I get, did anybody have trouble getting all of their box plots on one picture? Some yes, some no. I didn't make box plots.
Is it like super necessary?
A box plot?
That they're on the same page.
So, is making a box plot super necessary? Yes, because that was one of the questions. Is having the box plot on the same picture necessary? No.
Good.
You're like, good, I didn't. Right, so for the coaches, it was your second question on your assignment.
It was the coach.
Oh, okay.
Yeah.
Oh, yeah, I did that. That one was
Heavenly
easy.
chocolate.
Oh, okay.
I did that.
So for, I think for your coaches one, you had two box plots. You had one that was for the new salary and one that was for the previous salary, right? And so you had one box plot and you had the next box plot, and that's totally fine, right? Because you're not really comparing a variable and then breaking it apart on other things. You just have two different variables and you're making a box plot, and they're not comparative. So why would you stick them next to each other? Okay. This, however, is one variable, and I'm actually classifying it by day of the week, or the date. Okay, so going back to our SaaS Enterprise guide, I hadn't showed you this one yet. Some of you guys figured it out, some of you not yet. So our summary statistics, so I'm doing net sales by date. We're going to modify the task. All right, I want basic summary statistics. Tell me about the average amount that a customer spent, so an average net sales. So my analysis variance net sales. And I'm going to classify by the date of purchase. When I classify by the date of purchase, this is what I get. This might help you with heavenly chocolates. Does this help with heavenly chocolates? So your other option, modify task here. If I didn't use it as a classification variable, I might have grouped. It says group analysis by. So maybe I want to group my analysis by the date of purchase. Okay. And when I do that, I'm going to run it. So it still breaks it apart. Here's the 18th, and here's the mean, and here's the 19th, and here's the mean. And now I get a bunch of different, I'm going to get 7 different box plots. Okay. And this is fine. Right? You have the information. Yes.
So for our homework assignment, I divided by the dates and did the classification by the days. Do you think it's necessary for that assignment to have like the visual representation of it as well, or is just the analysis variable chart enough?
Did it specifically say you had to have it?
I don't remember.
I don't either. We'll check in a second. I think that probably falls under the do this by day, and in that case, I don't care. So unless I specifically said make a box plot,
Okay.
then so yeah. So for the heavenly chocolates, there's a good chance that I could get 10 different representations of the assignment, and that's totally fine. I left, question 1 is very vague in terms of give me descriptive statistics and give me visualizations. And some people are going to go the histogram route, and some people are going to go the box plot route, and some people are going to do other things. I don't care. As long as you can answer the questions and you have visualizations that back it up, or tables.
Yeah, mostly mine was tables.
And that's okay.
Okay.
That is okay. So I'm going to go ahead and modify that. Well, I don't need to. Okay. So either way works. I like kind of the all condensed table just because it's a little bit easier to read. All right. So going. Again, if you find something, if you have a question about, so maybe I want to know, next business question, for our loyalty customers, is there a relationship between the amount they spent during this promotion and the amount they spent in the last 12 years, or last 12 months? Yes, 12 years. Talk about retention. Okay. So what's the first thing I've got to do to answer this question? I'm just going to have my loyalty customers.
Filter it.
I've got to filter it. I'm actually left that part off. We'll add that on. Right? First, I got to filter. Filter and sort. There we go. Okay, so first I got to filter. So I just need my loyalty customers, and then you guys have finally, everybody's figured out the idea of the correlation. We're going to go to correlations now. So multivariate, so analyze multivariate correlations.
Oh, thank goodness. Mine looks like that.
Okay, so you have the correlation procedure, and it tells you the value of the correlation, or you can just do the scatter plot. Nice scatter plot. So here, is there a correlation between?
Yes.
Yeah, there is. There's a big, nice linear correlation. So if you spend a lot in general over the past 12 months, and you probably spent a lot during this promotion too. That's good to know. That can help us. Are we targeting our big spenders, or are we targeting our less big spenders?
Can you go back?
Sure.
What was that number underneath the correlation coefficient table? What is that?
That is an excellent question, and next week you will know the answer.
So by looking at the coefficient,
Yes.
we would be able to understand if it's a strong correlation or not. So can we just look at the scatter plot and say it without the prediction eclipse?
So you don't need the prediction eclipse.
I mean, you would have done it using the multivariate option.
So you could do it either way. So you could do just like there's a graph scatter plot,
Yeah.
and that's totally fine.
And then how do you figure out the relationship? I mean,
So
you have to-
then, that's the catch. So then to actually get the correlation value,
right.
you have to go to the analyze multivariate correlation. So yeah, so you could totally just make a scatter plot that doesn't have, so it wouldn't have this, right, so it would get rid of this, and it would get rid of this. And you could just make a scatter, and get rid of that.
But it's nice to have that.
And then you predict looking at the scatter plot.
And so, at this point, you could go either way. Question 2 actually asks you what is the correlation
Yes.
coefficient, and that's how you would get it. You could just look at the scatter plot, and you could say, it appears that there is or there isn't a correlation or not. But it's also nice to just have that number.
So it also depends on the level of correlation, like strong, moderate,
Mhm.
right?
So yeah, so like this one, we would definitely say that's a strong, positive correlation. But there's some, if you'll start to look at it, I've had a couple of conversations with people like, I was actually surprised. Like, it looks like it wasn't that strong of a correlation, but then you see the correlation coefficient, and it was like, that was still pretty high.
Yeah.
And so we'll deep dive into correlation coefficients when we get to regression at the end of the semester. But this is just kind of an intro to it.
So it also says that the correlation coefficient will work on the linear relationship.
Yes. So this only works for linear relationships. So the Pearson correlation coefficient only works for linear relationships. There are other correlation coefficients. Again, we'll talk about those later.
So suppose there is not a linear relationship and you apply this graph, what happens then?
Right, so if there's not a linear relationship, then you could be like, well, there isn't a linear relationship. Or you could say that there is you would just describe the relationship.
So the coefficient will be like really low?
It could be deceptive in multiple ways. So yeah, we'll spend like a whole different correlation there. Yes?
I guess you just said we're gonna have this later,
Oh.
but I was looking to find like, how do you know if it's like a strong relationship versus like
Moderately strong.
Totally depends
Okay.
on your subject area.
oh,
Right.
because I found on Google, it's like anything above like 0.5 is considered
Yes.
like
Yeah.
fairly decent. I was like,
And so then the question I would ask you is, who's that source?
I have no idea.
That's fine. But the reason I ask that, right? So if I'm in a hard science,
Yeah.
a 0.5 correlation, that's nothing, right? I need a 0.8, 0.9 before I'm going to say it's strong. But my background is education, right? And again, when we talk into regression, we'll really talk about kind of what these values can represent. If you square this value, you talk about the amount of variability that can be explained between these two variables, right? And so, in education, if I can explain 40% of the variability, because I'm in a social science field and there's all the things that happen with people, if I can explain 40% of the variability, I'm happy. But if I'm in hard science and I'm doing some controlled lab experiment, I'm only explaining 40% of the variability, I need to pick a different, there's something going on. I'm missing something. So yeah, so it depends on your context. Somebody, do you have a question? Or are you good?
Oh, I was trying to.
Okay. Anybody else?
How do you get the eclipse line on your scatter plot?
If you go through the,
I did that.
it should just automatically pop up.
No.
So it's, but it didn't. So in the plot, no, in the results, data, I think it's data, you pick which two variables, and I think the next thing is results.
There's a box to check mark.
There you go. You're like, let's just look since we have this on. Okay. So here I've filtered by loyalty. Here I am, where's my correlation? Correlation right here. Net sales versus preferred spend. So if I go to modify my task. Okay, so what I've done at this point, I go to my input data, so I've analyzed, I've done multivariate, and I went to correlation. Everybody's good there. I modify my task so I can see what it is. So the data, I brought over new net sales and previous total. And my options, this Pearson correlation, that's what we're doing because we're looking for a linear relationship. These other things, we shall talk about later. Results, I can click create a scatter plot for each correlation pair. And then make sure that all three of these are checked. Results to display, statistics for each variable, significant probabilities. Output data you don't have to worry about. The titles, you guys all know that if you want to play with this and change the titles and stuff, you're more than welcome to. But you absolutely don't have to at this point. We'll get to that, but right now, the properties are just, hey, what's going on? So if you have all those checked, yep, you check that and then check these three. It should totally work. You also get the scatterplot matrix thing, which is really pointless if you don't have. Now, when you have more than two variables, then this is kind of cool. But when you just have two variables, you're good. Other questions, comments, thoughts? So I know this is kind of like recapping. We spent a little while recapping kind of what you've already done. But have I answered your questions, or are you just totally bored? You're like a little bit of both. I'm not going to tell her I'm bored, but I kind of am. Okay, fine, we'll move on to new stuff. So the last thing we had, and this is where we ended last week, right? Which age group do we need to direct marketing efforts towards? Well, all that we have in our data set right now is birthdays. So we had to create an age variable, but then that doesn't totally help us. So then we had to create an age range variable. Then we can look at our age ranges, because it's a new variable, so we want to look at it and make sure it makes sense. And then we can actually answer the question of, get some descriptive statistics and figure out what we want to do as far as our marketing. Okay. So this one business question actually has quite a bit of stuff that we have to do to be able to get there. So here's kind of the output. So this is what I'm going to show you in this guy right here. So we're down here, Query Builder adding variables part 2. I'm pretty sure that's what I'm going. So Query Builder adding variables part 2. And I just added part 1, part 2 as I needed to go. And the reason you can't do it all in one Query Builder is because sometimes you create a new variable, and then sometimes you want to do something with that newly created variable, and so you have to create a new Query Builder to make that happen. Okay, so in this case, right now, all we have is birth date. If I scroll over, I've already run it, so it works. So if we go to Modify Task, and I look at my computed columns, we're going to look at timeout. We're going to go one down. First, we have to create age. So age is actually in Query Builder, the adding variables. It doesn't say part 1, but part 1. So Query Builder, adding variables. We're going to go modify a task. We're going to go to our computed columns. And here's where I'm going to calculate an age. Okay, so this is what I do the first time. I have new age. And I'm going to edit it. And what we're doing is I'm actually doing an advanced expression here. Okay, so I'm not recoding a column. I'm doing an advanced expression. And the expression is YRDIF. So your diff. We're going to pick the variable that we're interested in this case is birthday. We're going to pick the day that we want to do the differential from. Okay, so for me, I picked the first day of the year. We could actually pick today. Okay. So if you wanted to send out birthday mailers, right, or birthday emails, you could actually pick birthday, pick today, and then you would go through and you look for everybody who doesn't have a decimal point. Ooh. Right? So you have a decimal point, then your birthday is not today. If you have no decimal points, then your birthday is today. Right? Because you're looking at the difference. So the difference between your birthday and today's date, if there's no decimal points, crazy things you can do. Okay. So we're going to cancel that. And so what I obtained out of this was this column right here, new underscore age. And you'll notice anytime I make a new variable, I just do new underscore and I call it the same thing. You can start giving it other names. Like you could change, I don't know, where it was like method of payment could be payment method. Right? So you can start doing stuff like that, but I just add new underscore whatever. So that way I know, hey, I made this variable.
And then did you just make that second column just to clean up the decimals?
I did, yeah. So I'm like, so here's all these decimal points, and I just really don't care that you are 64.09 years old, or 14. So if you like it, then you're good, right? For me, I just wanted an age because I needed to get rid of all those decimals to make those age ranges nice and happy for me. Okay? So the way I created new age, again, love that Query Builder. going back to computed columns. And this one, because I didn't really change much to it, I just changed the formatting. I just made my underscore like double underscores. You guys can do whatever you want as far as naming conventions. You just want to kind of be consistent. And so what I did is if you add the advanced expression int, that stands for integer. So what it does is it returns the integer value. It doesn't round, it truncates to the integer. Okay? Which is great for our birthday because I don't want to round up. Right? So if I'm sending this out in March and your birthday's not until November, I don't want to be like, hey, you're 25, when you're really still 24. Even worse, hey, you're 21. It's like, nope, just kidding. Depending on my business, that could be a huge deal. Okay.
So why did you do that as a second query instead of editing the first
You
one?
can do it in one.
Yes, you can absolutely do it in one. The reason I did it in two was because I was trying to think like you guys.
Okay.
I mean, really, right? So, like, I'm doing this, and I get new age, and then I'm like, okay, well, crap, that's not exactly what I want, so how do I change it? So I wanted to be able to show you all the process. Yes?
So we create all these labels for our convenience, right? Like, say, new age rounded or something like that. But when we make a table, we don't want that to come. So is there any way where we can change the title of it?
So I didn't do this, but I could, and let's see what happens. So again, we're going to go to Modify Task. I'm going to look at my computed columns. I'm going to edit my new age. Oops, not new, edit. And step one is we make the expression. And step two lets you give me a column name, which is what ISYS is going to recognize. But then I can give it a thing called a label. And so the label is going to be age. And that totally works.
What does that do?
So it means when you print stuff out, it should print out the nicer label as opposed to the variable name.
Gotcha.
It should. We're going to try it, and we'll see what happens here in a second. Okay. So I'm going to make this change, and we'll see what happens.
It's not much of a problem for tables because table you just copy and paste it in Word, you can still edit it.
Yes.
But it's a problem
But
with
for
the
figures?
graphs.
All right. So we did that. And now that I've made some change, I'm going to run this. Okay, so you're going to see the variable name is going to stay the same. It's still going to stay how I made it. But now my label should be age. So we'll see what happens. So then the next thing I want to do, go back to my question, which age group? Not which age, but age group. So now we know we love our query builder. So if I try to add another computed column right here, new, and I'm going to recode the column because that's how I make groups. So we recode column, and I click next. You'll notice that age isn't there for me to choose from. Okay? Because it's a computed column. And if you go over here, so if you go a step back where you can see this age, and you try to do something from an existing column, the only thing you can do is just edit in here, building that advanced expression. So none of that works. So that's why I have to do the extra. Okay, this query builder is done. Now we're going to go to query builder part 2. So in query builder part 2, this is where we're going to change it into an age range. I'm going to modify the task, computed columns. And at first I did an age range of 10. Right, so everybody's comfortable with doing this now? Between this value and this value, make sure that they all have quotation marks around them. Alright. If you have questions, let me know. And then, after I did some analysis, I came back and I'm like, you know what, an age group of 10 isn't really what I'm looking for, so I also did it by an age range of 5. See if it made a difference. So now I have 2 columns, one with an age range from 10 and one with an age range of 5. So when I did my solutions, here's my age range of 10, and I can see my frequencies, and really it looks like at 10, everything looks kind of the same. No big deal. Go back, because I don't think I actually ran this. I'm going to edit this, and instead of using an age range of 10, this time I'm going to modify the task. And I'm going to do an age range of 5. So I'm classifying net sales by an age range of 5. Everything else is staying the same. I'm going to run it. And that's not the one I wanted. I wanted this one. I wanted to do a one-way frequency. Sorry. So, the one-way frequency, instead of looking at this, 'cause I'm like, man, there's a lot of people from 10 to 19. That's kind of a weird range for like shopping for clothes. So now I'm going to look at modifying the task. Again, instead of an age range of 10, I'm going to do an age range of 5. I'm going to run it. So still a lot that's kind of the same. Goes down a little, you can notice it goes down a little bit more here, but that we saw before. But what surprises me, I got 60 people in the 10 to 14 range.
Seriously, have I?
Right. Who knows what we're doing here, right? Like maybe we're buying something for mom, maybe this. I mean, but what store really has from 10 to 70? Everybody likes to shop here. Maybe our store's awesome. Who knows? Just things that show up. All right. Questions, comments, thoughts?
Actually, we don't know whether this age is the age of the person, the dress, or the age of the person who paid, right?
Well, and that's the part that kind of worries me is these are all credit card sales. If I've got the 10 to 14-year-old playing with a credit card, so to me, part of that makes me wonder about the data integrity and about the birth date, right? Because remember, we calculated age from a birth date. So did the last 2 digits get transposed? You know, should we be looking at people who were born in 59 instead of 95? You know, so that may be something that we may want to look into. Or we may be okay with this, or we at least want to have a story for why this is plausible. Okay. So this is kind of where we are. How about if we do this? And then we'll come back and we'll talk about confidence intervals for the rest of the class.